So next, I'd like to go through part 3, which is accuracy of the imaging diagnosis of lymph node metastasis. So we use the CT, MRI, or other techniques to differentiate or detect the metastatic disease from normal or reactive lymph node in a head and neck cancer patient. But how accurate we are, how good we are, or how good those imaging techniques are, that we need to investigate. So just a briefly, diagnostic criteria could be a size, would be one very standard things that we measure. The short axis diameter larger than 10 millimeter or 1 centimeter. The round lymph nodes are most suspicious for flat or oval kidney-shaped lymph nodes. Maintaining a lymph node highland fat will be indicative of benign disease. If you have a many lymph nodes in one specific location, with respect to primary tumor, you may suspect more metastasis than otherwise. Central necrosis, characteristic for squamous cell carcinoma, is area of less enhancing or hypodense area. That makes you suspicious for nodal metastasis if you're dealing with a patient with squamous cell carcinoma, despite the size of the lymph node. Extracapsular spread is the cancer spreading outside of lymph node capsule. This is a very common in a large lymph nodes, not typically seen in a small lymph node, but when you see it, it's important findings to let your provider know because it changed the management. So let me show you a couple of examples. This is a classic case of a central necrosis from squamous cell carcinoma. A patient has a tonsil cancer extending to the base of the tongue, and there's a bilateral nodal disease with central necrosis. You see the central area is less enhancing compared to the periphery of the lymph node. Because the tumor, it takes time to enhance, get a contrast enhancement than normal lymphoid tissue. So the area, it's not necessarily cyst, but it's necrotic tumor inside. When you see it in a patient with squamous cell carcinoma, you'd be pretty confident that is what you're dealing with. Oops, going backwards. Okay, even though the small lymph nodes, like this small lymph node, about sub-centimeter lymph node, you may be able to see this central necrosis. So if you're doing MRI, you have to do fat suppression for head and neck cancer. Extracapsular spread, or ECS, is commonly seen in a large metastatic lymph node, like in these cases. You can see this large necrotic lymph node. The finding is you lose the fat playing around the lymph node, almost like a lymph node mass is infiltrating adjacent normal structures such as the sternocleidomastoid muscle. It's sternocleidomastoid muscle should be there somewhere on the right side, but you can't tell because it's all embedded into the nodal masses. Another extracapsular spread, this is the 3 different patient. Notice there's a large necrotic mass, and enhancement extends beyond the capsule lymph nodes. This is necrotic lymph node on the contralateral side. Again, when you see MRI with fat suppression, you see this enhancement outside of the lymph node capsule. When you see it, it's you can be very confident that you have extracapsular spread. This is not easily to surgically cure by resection. Again, another patient, very infiltrative enhancement extends beyond the capsule. And also sternocleidomastoid muscle is invaded by this nodal masses, so you don't really see the distinct border. You can see extracapsular spread in a relatively small lymph node metastasis. For example, this is the undifferentiated carcinoma, blood product gland, this level 5 metastasis. Notice the spiculated border. So when you see on the post-contrast fat suppressed images, you have to raise the suspicion for ECS. Now, carotid artery invasion is very important findings because if you're encased in the carotid, the surgeon will not touch the patient. And oftentimes it's been said that more than 270 degrees of encasement or surrounded by the tumor is likely tumor involvement, but sensitivity and specificity is very suboptimal, or perhaps they don't really intervene if your imaging finding is suspicious, so it's very difficult to establish specificity. Anyway, let me show you some example. Oftentimes we see a lot of is basal tongue cancer with large nodal metastasis. It's not only that carotid is encased by the nodal metastasis, but kind of sandwiched between primary tumor of the basal tongue extending through the glossopharyngeal sulcus to nodal metastasis. And then the carotid artery is just right in between. So if this is the case, there's no way to take the tumor and a nodal disease with saving carotid artery. So this is the sign for not resectable carcinoma. When you're looking at the size distribution of metastatic and normal lymph node in the head and neck cancer, the metastatic lymph node is more very diffuse distribution. This is the size of the lymph node. And a benign node, the normal node has a high peak, about 6-7 millimeter. So the size criteria does not work so well in head and neck because many of the nodal metastasis could be similar size as benign lymph nodes. How do you measure the lymph node? This is a pretty often commonly seen question. And if you use the short axis diameter of 1 centimeter, which means the long axis could be 1.5, 1.4 centimeter, the sensitivity is about a coin flip, 50%. But the specificity is 95%, so you're not calling normal lymph nodes as metastasis. But when you use a long axis diameter for 1 centimeter, which means the shorter axis could be 7 millimeter, 6 millimeter, or 4 millimeter, the sensitivity is high, but the specificity is very low. So basically, you're calling all the small lymph nodes positive. So you're not missing metastatic lymph nodes, but you're over calling all the small lymph nodes are positive for metastasis. So either way, where you draw the line, there's always compromise based on just the size. For size criteria, there's an inherited limitation. One thing that I want to caution is now we have a multi-detector CT scan, so you can get a coronal reform out of images very easily. And this is the cases when I'm looking at actual images, I may not be too excited about this, but when you see coronal images showing more round appearances, and not only that, there's a central area of hypodensity, then you can be pretty confident that this is suspicious for nodal metastasis. This is a summary table of diagnostic performance on a CT scan based on the size. As I said, when you do large axis 1 centimeter cutoff, calling every small lymph node a metastasis, yes, sensitivity is very high, but the specificity is 1 digit. When you say short axis 1 centimeter, again, more forgiving, not to call every small lymph nodes, but a 1 to 1.5 centimeter lymph nodes with metastasis, specificity goes up, but the sensitivity is almost half. So what else we can do? Is there anything else we can do to be more accurate? So one thing that I love to do is dynamic contrast enhanced MRI of lymph node metastasis. So this is a patient with nasopharyngeal cancer, but metastasis to the right side of the neck. So you see this multiple large lymph nodes on the right neck, level 2 and then 5 zone. And this is the MRI scan continuously from before, during, and after injection of contrast. And you can tell the benign lymph nodes enhance much more avidly and faster, and then the washout. But metastatic lymph nodes tend to be a little slower, and enhancement lasts longer. So when you draw the line or time intensity curve with x-axis at the time, notice the benign lymph nodes go enhance very quickly and very avidly, and also wash out. But metastatic lymph nodes tend to be more slow or lower level lymph node enhancement, and then kind of persist, doesn't really wash out. The point is when you scan the 4 minutes or so in a regular T1 weighted spin echo after injecting contrast, there's no whole lot of difference in the signal intensity between metastasis and a benign lymph node. Only difference is really hemodynamic behavior. So that's why DCE has a potential for detecting metastasis that are otherwise not being detected. You can do parametric map to look at a maximum enhancement or K-trans or time to peak those maps are readily available for clinical use. Another thing would be diffusion weighted images. Again, this is very heavily used in every oncology imaging. And this is a study summarizing an ADC versus a TSC MRI findings for cervical lymphadenopathy with pathological correlation. And you're looking at it, the sensitivity is about 84% and the specificity is 94%, which is far better than coin flip on the size based on the TSC standard MRI images. So per lymph node, you have a very high sensitivity specificity. Also per neck, just looking at the data based on the one side of the neck versus the contralateral side as a group, sensitivity and specificity is over 90%. So again, diffusion weighted images may be more specific, way more specific than just measuring the size. This is one of the paper and notice about this lymph node metastasis can be very confidently detected by diffuse ADC map and some of the cutting ADC cutoff values. So diffusion weighted images, there are multiple publications out there. Again, very good diagnostic performance compared to standard size per node analysis. Sensitivity specificity is about 90 percentile. So again, there's a potential tremendous opportunity for us to do better. Head and neck FDG PET is another one because the FDG PET scan is really heavily involved in all oncology images. And I think a PET scan is great, particularly for with PET CT that you can localize the area of abnormality constantly on the cross-sectional imaging. This is a patient with a paratracheal or level 6 lymph node metastasis. Notice there is a FDG PET uptake. And I think this one you can call based on just on the CT scan. I don't think we call that normal. But what we really didn't appreciate it was axillary lymph nodes. And I guess you could pay attention to it, but we don't pay attention to the axillary lymph node all the time. So this is, again, an advantage of PET scan that being able to detect something that are perhaps the unexpected location, metastasis in unexpected location. Again, this is a thyroid cancer patient, immediate post-op, so there's a post-operative changes, and well, this is a post-op, some edema, fibrosis, we don't know. But when you do PET scan, there are nodal masses or nodal recurrence and also residual uptake in a primary tumor site after surgery. So again, it is something that the FDG PET may play a role, particularly for poorly differentiated papillary thyroid cancer. Performance of the FDG PET scan is somewhat widely varied between 70% and 90% sensitivity and per level analysis. And especially a little bit lacking based on the full region of what's the diagnostic criteria, because you can be very inclusive to include any subtle uptake as a metastasis, then you could be having you have a high false positive, or you can just detect definite FDG uptake and then maybe missing some of the mildly uptake lymph nodes. So there's some variation of diagnostic performance.